MATLAB offers both traditional selection structures such as the family of if functions and also a series of logical functions that will perform the same task. The primary logical function is the find command. Is this find command, which can be used in place of the traditional selection structures and loops. So with find commands, it will search a matrix and then identify which elements in that matrix that meet a given criteria. Okay, remember the keyword find will search that matrix and then identify the elements, not the value that we are going to search. Okay, let's look at this example. So the US Naval Academy require applicants to be at least 5 feet and 6 inches tall. So if we convert, it is about 66 inches tall. Okay, the requirement. So we have this height vector. Okay, 1, 2, 3, 4, 5, 6, 7 of the 7 different persons. And then we have to identify which of the applicants that meet the criteria of the height, which is the 66 inches. Okay, let's open our MATLAB. And start a new script. Okay, this is example to use find command. Okay, first what we have to do is we have to define the vector of heights. So store it in the variable name height, and then we are going to use this square bracket to indicate that it is a vector or a matrix. Okay, so 63, 67, 65, 72, 69, 78, and finally 75. Close the square bracket. Use the semicolon to suppress the output. And then next we are going to use find to determine which values are greater than or equal to 66. Okay, so the requirement is 66 inches and above, so it means that starting from 66, 67 and above will meet the height requirement to be a US Navy. So 66 greater than or equal to. Okay, so this is the requirement, and we will store the applicants that met the requirement inside the variable except. So use the find open bracket. Okay, so here we have x. X here will refer to the vector height. Okay, height, and then insert the requirement greater than or equal to 66. Alright, then we run the section. So command window, okay, the find function will return these are the index number for elements that meet a criteria. Okay, so it means that the element number 2, element number 4, and element number 5, element 6 and element 7 meet the height criteria. But what if we want to know what are the actual heights are? So we can do that by calling the height element using the index number. Okay, but first I want to suppress the output here. I don't want it to be displayed on command window, and then I will call the vector name. Okay, inside here is it will show what are the actual values Okay, here is the element number of accept, and then inside this height, so it will produce what are the heights values that meet the height requirement. Okay, so I can run this section, but first let's clear CLC. I can run this section and I'll get this answer. Okay, so if the first one here, accept is only show the index number of the elements that meet the height requirement. But with this code, I can show the values of the heights. Okay, that met the height requirement. Apa? So I just miss a string here, this one, and then run it again. So this is what I did with the display and fprintf function. So I can suppress the accept. I don't want it to be displayed on command window, and run again. So I get this more readable report. So we could also create a table of those who do not meet the requirement. Okay, so we just add to this code table of those who do not meet requirement, and then we use display the following candidate do not meet the height requirement. Close the string, close the bracket, and then use fprintf. Okay, just write a similar candidate number 4.0f is 4.0f inches tall, backslash, and close the string. Oh, first, but you have to determine candidates that do not meet height requirement. So we store it in variable decline. So obviously use find command, but with height. Okay, so the condition will be less than 66. Okay, then after we have the decline variable, then only then we can use it to produce a table of result. Okay, so decline, and this one will show the values of the decline height. Let's try run. Okay, this one is not complete. Okay, so you get this one is wrongly typed. Okay, so observe on your command window, you have 5 candidates that meet the height requirement, and also 2 candidates that doesn't meet the height requirement. Okay, Now let's try combine the relational and logical operators to create a slightly complicated search criteria. So we are still using the Naval applicants, the Naval Academy applicants before, but now we insert another criteria, which is the age. The age must be at least 18 years old and less than 35 years old. So instead of the height requirement, the applicants must also fulfill the age requirements, which is between 18 to 35 years old. So first, what you have to do is create a 7 by 2 matrix of applicant height and age information. Okay, you can do like me here, or you can just redefine, okay, define vector age and then combine it inside the applicant's vector. Okay, so your MATLAB will define age first. So age is 18, 19, 18, 20, 36, 34, and 12. And then a height vector, which is 63, 67, 65, 72, 69, 78, and 75. Then we combine all these two vector age and height inside matrix applicants. So the first column is height and the second column is age, and then transpose it so that we have a 7 by 2 matrix named applicants like this. Next, we will use the find command to determine which applicants are eligible. So here maybe I'll insert comments. Use find command to determine eligible applicants. Okay, so we will store the results of the eligible applicants inside this variable name pass. And then we will use find. Find will search from this applicants matrix. Okay, so for the first column, it will go through all the rows inside the first column. So it will search for the height requirement, which is greater than or equal to 66, and then we combine it using this AND operator. So here we are going to insert the second conditions, which is it will go through the applicants matrix and then all the rows inside the second columns. So here we will search for the age requirement, which is it should be greater than or equal to 18, and another requirement for age, which is below 35. So that's why this is for the age column, it should be below 35. Okay, let's try run. Okay, then we will get these results. These results is the index number, okay, 2, 4, and 6 of the applicants matrix. We then use fprintf to send the results to the command window. But first we have to group the results into a table. Group the results into a table. So results. Okay, the first column is pass. And then it will show the applicants that pass according to the first requirement, and then finally the second requirement. Okay, so let's see what we will get from this code. Okay, so element 2, 4 and 6. So this is the height. Second row show the height, and a third row show the age values. Alright, and then we will use the fprintf. So we want it to show, or we want it to be displayed on command window like this. So applicant number is the height, inches tall, and the age. Press all, backslash, and close the string, comma, results. Okay, run, and then we get this. We can suppress the output of the results, run again, and then we get this more readable report. So far, we have used find only to return a single index number, but if we define two outputs from the find command, as in like this here, so if we define these two outputs from the find command, it will return the appropriate row and column numbers, also called the row and column index numbers, or the subscripts. So let's look at another example of find. So this is temperature measurements of patients measured in a clinic. So it have these 3 different stations, and these are all the values of the temperature. So your task is to use find command to determine which patients have elevated temperature. So elevated means that the temperature is greater than 98.6. It should be Fahrenheit. Okay, elevated temperature means temperature that is higher than 98.6 Fahrenheit. So let's head back to our MATLAB. So first we have to define the matrix temperature, 5.3, 100, and this is the last row, 100.1, 99.3, and 97. Close the matrix, suppress the output. First, let's clear CLC here, and then we want to find the element number for the patients that have elevated temperature. So find temperature greater than 98.6. So with this code, MATLAB will return this single value number 3, 4, 5, 6, and 8. It shows the single index number referring to the temperature matrix here. When the find command is used on a 2D matrix, in this case this is a 3 by 3 matrix, 3 rows and 3 columns matrix, it will use an element numbering scheme that works down each column one at a time. So the numbering start down each column one at a time from top to bottom. So the element index numbers shown here is actually counted like this. Okay, so the results for the element that have elevated temperature is shown in bold numbers here. In order to determine the row and column numbers, we need to use this syntax. Okay, you have to call out these two different outputs, row and columns. With this, MATLAB will show the corresponding row and column numbers, and then these numbers will identify the elements shown here. So the red font color show the elements that meet the criteria. So for example, row number 3, this is row number 3. Okay, this is row and row number 3, and column 1 is this one, row number 1 and column 2, row number 2 and column 2, row 3 and column 2, row 3 and column 2, row 2 and column 3, row 2 and column 3. These are all the elements that meet the criteria of elevated temperature. Finally, you can use the fprintf to create a more readable report like this.